So this is a video on water pressure and how it's created. Now there are three ways to create water pressure. One is gravity, which we see every day when you drive around town. You see these big water towers and the pressure is being created by gravity as the water goes down. The second way we create pressure is with a pump, and again with those water towers they have pumps inside them, so they're pushing the water. The third way that we can create water pressure is with heat. Now that's something that you don't see too often around here. Your house, the water that goes to your house is going to be generated, the pressure is going to be generated through gravity and through a pump. Let's look at this example. We have a garden hose and right now it's open and water is shooting out of the end of it. Now the water isn't shooting very far. If I put my thumb over the end of it, it's now shooting a lot further than it was before, just by me putting my thumb over it. But have I actually increased the pressure? No, the only way you can increase pressure is gravity, a pump, or heat. So what's going on when you put your thumb over the end of the hose? Well, the PSI remains exactly the same. When you put your thumb over the end of the hose, what you're actually doing is you're restricting the flow. You're restricting the amount of water that can go out of the end. So it looks like the water is got a higher pressure because it's shooting further, but in reality, the pressure is almost identical. The pressure when the hose was running without my thumb there was about 60 PSI. The pressure when I put my thumb over it was still about the same, about 60 PSI. If anything, it would be slightly less because the flow was being restricted. What does this matter in terms of the context of irrigation? Well, when you install a sprinkler system, you start off with your main line, which is going to be the largest pipe. And for residential, we tend to use 1 inch. And then when we get to the valve and then the lateral line, we start by running 1 inch and then we reduce down to either 3/4 or half. Now, a common misconception is, oh, we reduce down in our pipe size to increase pressure. The only reason why we reduce the size of our pipe is cost. That is it. It is only cost. If you're installing a system and you're not sure, so you're about to install it and for some reason you didn't get a plan and you're like, man, I don't know where I should reduce down, don't reduce. If you have a system and you're not sure what the gallons per minute are, you're not sure what the pressure is, run everything in 1 inch. If you run everything in 1 inch, that means that you are not restricting the flow on any part of the system. So I'm just going to repeat that again so everybody in the back can hear it. There are only three ways to create pressure: gravity, a pump, and heat. Reducing the pipe size is for cost, and that is it. So if you have a scenario where you're not sure what to do not reduce. Keep it at 1 inch or whatever you were installing at. So if your main line was 1.25 inches and you're not sure, run everything 1.25 inches. Of course, it's going to cost more money, but you're going to guarantee that the system works at the end. When you reduce the pipe size without thinking about the hydraulics, what you're doing is you're restricting the amount of water that can get through the system. So you may still end up with a scenario where you have the right pressure, but you don't have the right quantity of water to actually pull up all of the heads and for every single emitter to be shooting the distance they're supposed to be shooting.